Hey there. So here's some solutions for you for the couple of problems that you mentioned. So this is number 7 from the practice exam. In each case, give the percent of the new hourly wage needed to return to the original hourly wage. So I'm just going to go through one, and then these are kind of transferable. So you can kind of set them up the same way. So your hourly wage of $10 is cut by 8%, and we're looking for the percent of the new hourly wage needed to return to the old hourly wage. So this is going to be a 2-part problem. So we're going to start out with the original, the cut, and the lower pay in percent and dollars. So you are making $10 and it is being cut by 8%. And we always use the original as the 100, and it's an 8% cut. So this is going to be 92, and we're going to look for this value. So I'm going to have, actually we can just factor of change this one, divide by 10, right? And so that means that you end up with a lower pay of $9.20, right? So that's your lower pay. And so then the question is, what percent do I need to raise it in order to get back to your original? So essentially your chart's going to flip. So you're going to have your lower pay and percent and dollars and raise and then higher pay. I don't want to use original here. You're really going back to the original pay, but I don't want to put that in here because I don't want to confuse you with the 100%. So now you're starting at your lower pay. So that's where my 100% goes. And we want to know what's the percent raise that you need. So this is what I'm looking for. And then we know that the lower pay is $9.20 and the higher pay is $10. So we need to get a raise of 80 cents. And so from here, then you can go ahead and cross multiply. And that's going to give you 920x is equal to 80. And so then x is equal to whatever that's going to be. Okay, but each time you're going to set up that same procedure where you start with your original, use your pay cut to find your lower pay, then set up a new chart where you start at the lower pay. So now your lower pay is 100%, and you're asking what percent raise do you need to get back to $10. Okay, and so the same kind of setup for each of those. You're just going to switch out the dollar amount and the percentage. Now on the last one, when it doesn't give you an amount of money, you can either pick one or use a variable to hold that spot, right? So that you can kind of see what's going on. Okay. The next one you mentioned was 9B. Okay. So Ashley bought a shirt and pants for $91. The pants were 60% more than the shirt. What is the cost of each item she purchased? Now I feel like you asked a question about this. Why the boxes and how do you know how many? Okay. In 9B. So this can definitely be done using boxes. So I think that most likely what I did, and I'd have to look at the solutions again. So 60% is 60 out of 100, which reduces to 6 out of 10 or 3 out of 5. So if you're going to use boxes on this one, then this ratio, the 60%, relates pants to shirt. So that means this is pants to shirt. So if I'm setting up my boxes, pants would now get 3 boxes and shirt would get 5. Now, if I use 6 and 10, then I just use this ratio as instead of reducing it all the way. Okay. And then, of course, you set up the boxes. So my total would be 8 boxes equals $91. Right? And you're going from there. Okay. Now, if you didn't want to do that, it's because it says use a picture or diagram, which is why I did it using boxes. Okay. If it doesn't say that, then you can go ahead and set up your chart, in which case you would have shirt, pants, total, percent, dollars, and total is $91. The shirt is, pants were 60%. Oh, I'm sorry. Hold up. back this train up. And this may be the issue. The word more here. The word more goes in there. Okay, so the pants were 60% more than the shirt. So if we go back here to our 60%, 60 over 100 reduces to 3/5. But the pants aren't 3/5 of the shirt. That would make it less. We want this to be more. So that means we're going to add the two together. So we're going to take 3 plus 5 over 5 because it's as much as the shirt. So 5 plus 3 more. And that's going to give you 8 and 5. And so that means that your shirt and pants, for shirt is the bottom, pants is the top. So we get 5 boxes for shirt and 8 boxes for pants. And then you have 13 boxes equals $91. Which makes a lot more sense because I think that goes evenly and it gives you 7. So each box is $7. Okay, and you can calculate from there. Okay, so that's where all the boxes come from. And then lastly, you mentioned 10, D, E, and F. Okay, so if quantity X is 150% as large as quantity Y, then X is how much more than Y? So if I were using my chart with just percent, X, Y, and more, what comes after the percentage is your 100%. So that means percent sign Y is going to be my 100%. So Y is the 100%. X is 150%. So how much more is that? Well, it's 50% more. So that's what I would put in here. Okay. If John eats 165 as many calories as Jane does, then he eats how many more? Well, that means that Jane is the 100%. If John is 165%, then he's 65% more. If Christy spends 300% as much as Lana spends, again, percent, Lana is your 100, Christy is 300. That means this is 200%. Okay, and hope you can kind of set them up the same way using that little chart.